All right, so thank you very much to everybody for joining this talk on real-time machine learning with Python. There's a lot of really interesting content that we want to go through. We're going to be covering quite a lot of topics as we go through. So please hold your seats. It's going to be a very interesting area that I would also love to generate the discussion even after the talk to continue exploring best practices. So you can find my Twitter through this link that will be in the corner. I'm going to be publishing the slides and the code later on today. So if you want to get them, you can access it through my Twitter, and my GitHub handle is also the same. You'll be able to access them through there. So a little bit about myself. My name is Alejandro. I am the engineering director at Seldon Technologies and the chief scientist at the Institute for Ethical AI and Machine Learning. I'm going to talk a bit more about that in a second. But primarily my background is as a practitioner, software engineer across hands-on and leadership roles, currently leading a set of teams for open source machine learning. And more specifically, my role at Seldon encompasses our open source production machine learning deployment framework for Kubernetes. We focus primarily in the life cycle of models once they have been trained, and all the complexities that come around productionization of machine learning. So a lot of the things that we're going to be talking about today, it will involve the best practices that we've identified when performing real-time, as well as just general large-scale machine learning deployment. Although today we're also going to be diving a little bit into the training side. And also my role at the Institute for Ethical AI and Machine Learning. This is a research center that focuses on developing work towards responsible machine learning. This is primarily through contributions to ongoing standards, as well as working groups that are working in this type of verticals. Recently, one of our contributions was to the Association for Computer Machinery, the ACM. We published a statement on contact tracing applications, primarily towards the technological implications and best practices. So if you want to check it out, please do, and any thoughts are appreciated. And the Institute is also part of the Linux Foundation. We're quite excited that a lot of contributions are still in the intersection with open source. But today we're going to dive specifically into a conceptual introduction of stream processing and just generally streams. We're going to also be talking about about machine learning and machine learning in the context of real-time processing, as well as some of the trade-offs across different tools and different frameworks that you can find to be able to leverage. And we're going to cover a hands-on use case of how to apply all of these things. And as I mentioned, if you have questions as the talk goes on, please ask them on the chat. I'm going to be stopping and addressing questions as I go to each of the sections of the presentation. So in regards to the use case, we're going to be doing real-time processing on a Reddit dataset. So Reddit, as we all know, calls itself the front page of the internet. So what we have is a dataset of Reddit comments from our science that have been removed by moderators, and we're going to be building a model using this data set. And we're going to be aiming to fix the front page of the internet, because we can all agree that the internet is not the full of just positive stuff, but at the same time, we also want to dive into some interesting things that we can see on the exploratory data analysis of this data set. So of course, we're not going to have time to do all of that, but after the talk, you can actually dive into some of the data exploration on the Jupyter notebooks. But before diving into streaming, we need to take a trip to the past. And really, this is not even a trip to the past, because this is the present, right? And the present is ETL. What is ETL? ETL is, as you can see in this architectural diagram, the concept of extract, transform, load. That basically means you take a data set, you do something with it, and then you put it back somewhere else. And this is how the data processing world has worked since the Stone Age, right? Ultimately, it's not about like real time events. It's more about like you take a batch, you do something, you put it somewhere else. The reality is that the world still functions this way, but at the same time, we're moving more towards this real time piece. But I want to dive into this concept of ETL because it's still so prevalent. And the complexity doesn't only come with this ETL, three-letter acronym, is that you not only have ETL, right? You also have ELT, you have EL, you have LT, and you have tons of different types of combinations of this stuff, right? And the problem is that they're not all just terms that people throw away just because they feel like it. Ultimately, although sometimes that is the case, we all know. But the reality is that these terms actually do refer to patterns of data processing that are present in industry, and this separation is still important. And there are a large range of different tools that are available at your disposal for you to be able to leverage each of these different things: ETL, ELT, EL, ET, la la la, etc. Of course, there's large number of tools that are useless, but a lot of these different tools, they are very good, very specifically for certain areas, and they're best when facing specific challenges, right? And more specifically, some of the tools that fall into this, in the context of extract and load instead of transform, is things like Flume or NiFi, Apache NiFi. Flume basically allows you to move data from different databases. Ultimately, NiFi, as you will see with other tools, it tends to be very ambiguous of the division, because, for example, with NiFi, you also they also leverage a lot of the transform step. So although it is used a lot to move data around, it also can be used for actually transforming it. Now, in the extract load transform, that would be more on the data warehousing perspective, right? You load your data to something like Elasticsearch or some data warehouse, and once data is loaded, that's when you actually transform it, right? And then there's others like ETL, which is the sort of like more common extract transform load, which encompass all of the different areas, and these are tools like Oozie or Airflow, if you have heard of that. But today, we're going to be using a good old ETL step, where the transform step is a human with a Jupyter notebook, right? So that's going to be in our case our non-real-time process, and what we're going to be doing in the context of ETL is going to be the training of our model. And the reason why I'm talking about ETL and batch is as a step towards this concept of streaming. And the reason why is because batch and streaming ultimately get brought up in the context of, is it one or the other? When should you bring it? When should one be better than the other? But in reality, what we're starting to see is that, of course, you have some tools that specialize into the streaming world, and you're going to want to be leveraging them in the context of, eventing or real-time processing. But there is a larger and larger intersection of both platforms, of both concepts, and even more of an overlap that tools try to unify those. And more specifically, you often find yourself where you actually need both. And today, for example, we're going to be training one model, which is not going to be real time, but then we're going to be actually putting that model in production for stream processing, right? And it's ultimately going back to that massive ecosystem that we were talking about. It's not about just running with a hammer, trying to find a nail, but it's instead trying to understand what is the right tool for the challenge, right? And then, as I was saying, right now there's this massive trend within the streaming world to unify both worlds, batch and streaming, right? The streaming community is trying to bring in this concept that when it comes to stream processing, if you take a batch of data, it would be the exact same as if you were just, just streaming that. So if you take a file and you pass it through a stream processor, that would be still in the same sort of framework that could be used. And at the same time, when you take a real-time stream, let's say, for example, events that are coming out of a system, you may want to also take batches that would be used for processing. And tools like Spark actually do this, where they actually use this concept of micro batching in their stream processing, where, as you're aware, I'm still going to go into detail in case you're not as familiar. Apache, that technology, what it basically does is it allows you to actually process large-scale sort of data sets, right? Apache Spark is able to distribute horizontally that massive data set that may not fit in memory, and then process it and get some insights. However, when it comes to Spark streaming, what it basically does is it actually takes chunks of the stream and then sends it to Spark so that it actually processes it in micro batch. And the stream community, they basically say, this is not real streaming, right? It's fake streaming. That doesn't count. I do have to say that in the more recent versions of Spark streaming, they actually introduced the ability to be able to process in actually every single data point, as opposed to micro batches, right? So that's just one thing to mention. But yeah, what is interesting here is that there is a lot of push towards this convergence of worlds, and we're going to cover this into a little bit more detail in a second. But before diving into that, I want to dive into some of the concepts that are specific into streaming. When you get a stream of data and you actually are processing that data, you have new concepts that are quite common in that community, but are important to gain as foundations, so that when you approach a challenge, you can use those best practices. The first one you have most probably already come across, that is the concept of windows. This is basically the ability to take on a specific window of data points and be able to actually perform a computation that could be a stateful computation across that specific batch, right? So in this case, you can have tumbling windows, which is basically not non-overlapping windows, or you can have sliding windows, where basically you actually do overlap on the windows that you gather. And this is where the point about the unifying worlds come in, which is basically saying, well, you are dealing with a stream, or you can actually convert that streaming problem when it's necessary, of course not always, into this sort of like micro batch problem, specifically when you want to actually gather, perhaps, let's say, an average across every second, right, or something like that. And one of the things that we're going to cover, in 2 slides is specifically the concept of, the time of the events themselves, right? So you may want to have the actual sliding windows or tumbling windows on the time that they arrive, but perhaps you may also want to process to make these windows on the original event time, right? Because remember that, like, the time that an event arrives is not the same that the time the event was actually generated, right? So perhaps your windows are 1 second, not on the time that they arrive, but 1 second on the actual event time, right? So and this is something important. Bear that in mind, because we're going to actually cover that in a couple of slides, and that's going to be an important detail. The second point is the concept of checkpoints, and checkpoints are basically like how you have it in a game, right? In a game, when you reach a checkpoint, if suddenly you die later on, you return to that checkpoint, right? So in this case, that's the same intuitive concept, not the same, but it's an intuitive way to understand that concept, which is basically that you're able to keep track of consumers, basically where they were able to actually read last, right? And this is an important concept when it comes to streaming, because when you actually have a consumer, you can also have perhaps a consumer group, right? So you may have multiple different consumers actually reading from a queue, and you may want that the checkpoint is for the entire group. Now, checkpoints, the other important thing is to understand when you're actually marking that checkpoint. Are you marking that checkpoint on the moment that you read it, or are you marking that checkpoint on the moment that you're actually processing it, right? Because ultimately, when it comes to commitments that you can get when it comes to stream processing, you can actually have things like at most one delivery, at least once delivery, and exactly once delivery. And as people that have actually worked with streaming processing before, the exactly once is the hardest, and it's a really hard challenge that it has to be reassessed, and it has to be really thought well when implemented. There are some data streaming processing frameworks that offer it, of course, with some constraints and assumptions that need to be in place, like Apache Kafka, that allows you to define these things at least once, at most once, etc., etc. And of course, as you approach your use case, it's important to bear in mind which one to use. And now the key other point to cover is the concept of watermarking, right? So we talked about processing time versus event time before. And watermarking basically says, if you're perhaps doing a window computation, say perhaps you want to have the average of some attribute on every second, right? Your watermarking is basically saying how far are you going to be able to wait in regards to holding a buffer for you to be able to count events that arrive late, right? So you're processing on windows, not on processing time, but on event time. If an event that was supposed to come 5 minutes ago arrives right now, if your watermark is still 7 minutes or anything above those 5 minutes, then you'll still be able to take that and then bring it to that window, recompute the window, and have that to be able to use as your window processing. So the concept of watermarking is an important one, primarily as it allows for the ability to consider events that come later. And again, this is a component that has to be taken into consideration when building your stream processor, et cetera, et cetera. And some frameworks provide it out of the box. Some others, you have to build it yourself. And now, in terms of some stream processing tools, and it's important here that we're separating the stream queues, the queuing frameworks, from the stream processors themselves, right? And there are several processing tools that you can leverage, tools like Flink, which has been growing really, really fast, and they have support for multiple languages. Kafka Streams, this is from the Confluent team, which is the team behind Kafka. Spark Streaming, which is the one that I covered. They also support multiple languages. Faust, which is a Python-based streaming framework, I think is the one with the most traction, well, the most stars. I mean, arguably vanity metric, but they do have a pretty significant momentum and community. So that's the tool that we're going to actually be using today. And Apache Beam is another one that actually tries to focus on building that unified interface. So you can do batch processing and stream processing with the same sort of not domain specific language, because they have it on Python, but the same SDK. So you can write the same stuff, and depending on whether you run it with batch or with streams, it would choose the backend of Spark or Flink. And that's a very interesting area. And today, these are the tools that we're going to be using. We're going to be using for the stream processing Faust and Kafka. So, well, Kafka is for the actual streaming queue, and Faust is going to be the actual stream processor. For the serving of our machine learning model, we're going to be using Seldon Core, and we're going to dive into all of these tools. And then for the training, we're going to be using SpaCy, as we're going to be dealing with text, and scikit-learn, as we're going to be training a machine learning model. And what we're going to be doing is we're going to be following a traditional machine learning workflow. We're going to be taking some data, which in this case is a bunch of Reddit comments, some that have been removed by moderators, some that are not. We're going to then transform that data so that we can feed it into the models, and we're going to clean it. We're going to do some exploration, although we're not going to dive into too much detail in this talk, but you can check it later. We're then going to train some models, and in this case, we already have the code that generates the, I guess, semi-optimal model in this case. And we're going to persist that model such that we can now put it in production, so that on seeing new Reddit comments, as they come in, we would be able to classify them with that model. And what it basically will tell us is, as accurate as this will be on whether the mods would have removed it or not, right? So that's basically what we're going to be building here. In regards to the model training, what we're going to be doing is we're going to have this simple pipeline, right? And this pipeline is going to consist of a step that is going to basically clean the text, right? Boring, remove symbols, deal with localization, with encoding, all that stuff. Make sure that we are able to have some clean text, right? So the code is really that. Then next we're going to tokenize, and we're going to dive into what that is. This is with SpaCy. That's going to convert the text into actual tokens. Then we're going to convert those tokens into our TF-IDF vectors, vectorizer, and then that's going to be fed into our logistic regression model, our logistic regression classifier, right? And this is the parameters that we use. And the way that basically this is going to look like, an input. Imagine somebody leaves a comment, as you would in YouTube or Reddit, something like "you are a dummy." What this would happen is it would go into our clean transformer, clean text transformer. It would remove all the symbols, unwanted stop words, etc., etc. So it would go from "you are a dummy" to "you are dummy." Then it would actually convert into tokens. So in this case, it would be pronoun is dumb, right? And then it would actually vectorize it. I mean, this is fake news. It's not the actual vectors, but it would vectorize it. It wouldn't fit if I actually put that into the input that we can then feed into our model, which we're going to get our prediction whether this would have been removed or not, right? So as we pass all of our data, then we can actually train our model, and we now have a trained model. We're now going to take that trained model and deploy it. If you're more interested on the actual exploratory data analysis of the Reddit comments, it was some interesting stuff, but not like super groundbreaking. Spoilers, there's some bias. And ultimately, we also did some grid search to see how other models competed. We also trained it with a deep neural network, but we don't have a deep neural network sized data set anyway. So the key thing here is to show the stream processing. But yeah, you can check the SVM, the naive Bayes, etc., etc. So yeah, do check it out. So what we're going to be seeing here is, okay, what is our architecture of how we're going to be processing this data set in using our stream processing components? What we're going to have is we're going to have a source, right? A source of comments. We're going to have two key stream processor workers. They're going to be continuously, the first one is going to be continuously polling for new data. In this case, whenever a new comment comes in, the only thing it's going to do is it's going to take that comment and it's going to put it into the Kafka queue under the first topic. The topic is Reddit stream, right? So any new comment comes in and then gets put into the Reddit stream topic, right? So then after that, our second worker is going to be continuously listening to that Reddit stream topic, and it's going to be basically reading that topic, and is going to be pushing, running the prediction. What it means by running the prediction, it's going to be actually sending it as a request to our machine learning service, and then getting the prediction as a response, and then taking that prediction and putting it in the prediction topic. And if the probability is higher than 0.5, or the prediction is that the mods would have removed it, then it would then go into our alert topic, right? And we actually have another job that reads from the alert and puts it into Elasticsearch. But for the sake of simplicity, this is basically what we're going to dive into today. So let's first dive into the first component. Remember we are using this framework called Faust, which is basically a Python stream processing framework that actually has taken the best practices from Spark streaming and brought them into Python. And it's from this company called Robinhood. Pretty cool project. So what we've done is similar. If you have created a Flask application, like a Flask app, how you actually say, Flask app create, this is the name, this is the URL. this is how you actually start Faust. This is the URL of Kafka. This is what you want to read. And then what you basically do is you can actually use Python's Asyncio framework so that you can actually leverage these different components. What we basically are doing here is we're actually not listening for any topics, because what we're doing is we want to pull data. We're basically running a timer every decimal of a second. We're going to be running this function, and what this function is doing is we're basically fetching a Reddit comment, right? So if there's a Reddit comment available, is basically going to fetch that comment. It's then going to create that sort of data, and as we said, it's going to basically leverage again Faust. It's going to do app.topic. It's going to call the actual Reddit stream topic, and then it's going to send it. With Kafka, provide the ID and the value. So the ID is to make sure that you can have those, enforcing of only ones and most ones, etc., and you can have uniqueness on the key level. But yeah, so what we're doing here is basically just pushing that first topic every 0.1 seconds, right? New comment comes in, it gets put back. In this case, we could actually be polling more often, right? Or doing whatever you want. So then in this case, and just as a heads up, this function fetch Reddit comments, what it currently does, we actually have some code that can actually reach to the Reddit API, but they actually limit based on the number of requests. So here we basically have an offline data set that is loaded on a pandas data frame, and we just do .sample, right? So it takes a random one and then just sends it, right? So that's to simplify things. Then the second step is the actual machine learning processor, right? So what this does, it actually creates an agent. So that's how you do it in Faust, into a topic, a Kafka topic. So it basically continuously listens to the topic Reddit stream, right? And what it does is basically whenever there's a new topic, it's iterating across the topics, right? So the actual topic is passed here, tokenized stream, and then tokenized stream.items, and we do an async for. I forgot to indent this, but yeah. So ultimately, what you have is you first take the tokenized body of the inputs, and then you actually send it to the Seldon model, right? So in this case, what we're basically doing in the next slide is I'm going to be talking about what happens in this send function, right? Ultimately, we get the probability, and we then push that first into the Reddit prediction topic. And then, if the probability is larger than the threshold, then actually we send it to the alerts, right? So ultimately, what we're basically doing is as simple as it gets, and as simple as you're able to set it up, is to actually do that processing. One thing to mention is that with Faust, you can also introduce those constraints and those requirements of only once, or well, at least once, at most once constraints, primarily because that is the way that they're able to ensure they can consume from Kafka, right? Because Kafka is actually quite a sophisticated framework when it comes to actually consuming from that. You need to manage all the brokers, all of the different consumer groups, etc. So it does simplify a lot all of the stuff that you're doing. And just reverting back to some of the concepts that I mentioned in the previous slides, we're actually consuming based on a group, right? So if we were to shut this down, we are keeping track of where that consumer group basically is, right? And the way that this is kept track is using Zookeeper, which is another sort of like distributed data store that basically just keeps all of the areas where you stayed, right? Because if this dies, you want to basically revive it. Although you can actually set it up so that it actually keeps track of the checkpoints locally using RocksDB, which is quite interesting. I do recommend going in and playing with it. It's quite simple to get started. And then there's the question of, well, what happens on that request prediction function? What it basically does is we have a client that allows you to basically leverage and send requests. In this case, what we're doing is literally just sending a prediction request. So this is basically a HTTP request into our ML service. What this basically is a model that has been deployed. This is basically on a Kubernetes cluster. And this is basically reaching it through an ingress, right? So it's basically just sending a request, it's being routed to that model, and then you're getting the response, right? And we're going to now dive into the content, what is inside of that model. So how we actually, we looked at the code of the component to actually fetch the comments. We looked at the component that basically sends them for predictions and then pushes them. And now we're going to be basically look at the code for actually containerizing that. And just kind of like in sorry, like the way that the ML serving component works with Seldon, there are two ways in which you can take your trained model, your already trained model, and containerize it or basically deploy it, right? You can basically take a pickle, right? Your artifacts, like an exported pickle or version of your model, and use one of our prepackaged model servers, which are basically optimized servers that you can use to serve things like scikit-learn or XGBoost or TensorFlow. So if you have an off-the-shelf framework and you're using a simple model, you just export it and you just provide it, right? And you can make it available through an S3 bucket or an object store. But in this case, because we have a slightly more custom pipeline, you can build your own model server, or you can actually just build a custom wrapper, right? And in this case, that's what we're going to be doing. We're going to taking our code and we're going to be basically exposing it and containerizing it, right? And in this case, we're only going to be deploying one model, but you have the option of deploying like complex graphs, right? You can have the model that we have right now, and you can have like a preprocessor in a different component. You can add like text explainers, you can add outlier detectors, you can test a model as A/B test, etc., etc. So it deals with a lot of the complexity of production machine learning at scale, right? So if you were to update your model and you have a stream processing component that is critical for the organization and you want to update it, you don't want to have downtime, right? So this deals with the rolling updates, right? New model comes in, it takes on without interruptions, right? So that's the key thing about that. So the way that you would actually wrap models with Seldon, the only thing that you need to do is you need to actually write a class that wraps your model, right? In this class, what are we doing? First in our init function, we're loading the pickles, right? So in this case, it's our tf-idf vectorizer dot pickle, which basically is from our model that we trained. We just did like pickle.dump, and that dumps it into a binary file. This is basically just would be loading that, right? And then same with our logistic regression model. And the reason why we don't need to load a model for the clean text transformer and the SpaCy tokenizer is because the clean text transformer is not a model. It's just a bunch of regexes, right, or text replaces. And the SpaCy tokenizer, I mean, it comes bundled with the model, so we're just using the library itself. And if you see the ML utils, it basically downloads all of the required artifacts for SpaCy. And then this predict function is what is exposed through the endpoint, right? When you write your class, Seldon is going to basically expose a HTTP endpoint. Whatever you send as a request, as a JSON request, is going to be passed as this input, right? So in that case, what we were sending was the tokens or the text. And in this case, as it receives it, it's going to pass it through our entire pipeline, right? So, X gets passed through the clean text transformer, then clean text gets passed through the tokenizer, then tokens get passed through the vectorizer, then vectors get passed through the logistic regression model, and then returns the prediction, right? That's basically what it would be doing. Now, what then we do is we just run the utility, basically with Seldon, you're able to just run a command line, and then that converts it into the microservice, right? And then once you have that, it's basically that microservice that is able to listen. So whatever you send as requests here, that's what basically gets passed through the predict function, right? And ultimately, this in itself, then you have kind of like the entire workflow. Just to basically summarize, what we have here is we have a continuously polling component that is listening for new comments. As soon as a comment arrives, it pushes it to the first topic. Then we have another worker that is continuously listening. As soon as we have another, a comment that comes in, it basically receives it, sends it to our ML service, gets the prediction, puts the prediction into the first topic, and if it's a positive prediction, it puts that topic into the alert function, right? And then we have the other one, which is basically on the that pushes into the Elastic Stack. And yeah, so that's kind of like the overview of each of these components. You know, I do recommend you to give it a try. And you know, ultimately, kind of like to recap. You know, today we've dived into a conceptual overview of stream processing. We've covered machine learning, the training of a model, and then machine learning in the context of real time. Although we've only touched the very, very high level of each of those topics. We've covered some trade-offs across all of these tools, and we also covered a hands-on use case on implementing all of these tools. Of course, if you're interested specifically on each of these topics, I actually have some talks that dive specifically into the deployment of the containerization of the machine learning models. I encourage you to actually go and check that out if you want to see how to actually containerize the model, to deploy it. In that, I actually also deploy an explainer, and I show how to send the requests to the model and then to the explainer. And then also in terms of stream processing, I have some also repositories that cover how to do this with Apache Spark streaming, as well as with Spark ML, right? So you can actually dive into these topics into more specific detail. And kind of like just to mention the final point, if you're also interested in the exploratory data analysis, please do check out those other Jupyter notebooks. They're quite extensive, and they do dive into a lot of detail and explore every single avenue. Explore, like, you know, what times people posted, et cetera. You know, what are the most common words that appear in regards to like comments that have been removed. Of course, discretion that, you know, these comments are inherently not going to be very nice. So if you're easily offended, don't check the exploratory data analysis. But it is quite interesting. So with that said, today we covered real-time machine learning with Python. We dived into several of the core technologies, and I appreciate everybody that joined. I'm going to be sharing this video, and for the code and slides, yeah, please do check out my GitHub and my Twitter under this username. And I'll be posting all of the resources there. With that, I'll pause there, and I'll be able to take questions if there are any. Awesome. All right, yeah. So we have a question from Nokchan, and so he says, "Great talk. Why do you need to push data to Kafka topic first instead of just processing it directly?" That's an excellent question. That's a really good question. So the reality is you don't need to, but the question, the real question to ask is, will I ever need to have a component that will benefit from also listening to the raw comments or to the tokenized comments? So perhaps you may have other things that are actually consuming the raw comments to perhaps put them into an Elasticsearch database, similar to what I just mentioned here, right? So for example, you may be able to just have one processor that is sending it to the Elasticsearch database, processing the prediction, and, you know, pushing it to the output. But instead, what you can have is you actually put the raw strings or the tokens here, such that if later on the line you actually suddenly want to push those things to Elasticsearch, you basically, instead of modifying that component, that it's, you know, following the principle of, you know, doing one thing and doing it very well, you can actually add another stream processor that just focuses on taking that and then pushing it to the database, right? And then if later on you want to have another component that you want to do something else with the text, then you can actually add it later on, right? And then what that means is that if you need to update the component that actually does polling, right, you're not going to have to also modify the component that is doing the predictions and the component that is pushing to the database, right? So that is basically the main reason why there may be a design decision why you would want to push it to a separate topic, right? But that's a very good question. I mean, I think ultimately it's really based on design, right? And ultimately, perhaps it's always better to not over-engineer it. And I think, you know, at this specific point, it may be over engineering it, but you know, it's for the context of the talk. You can see multiple stream processors. Also, if I had just had one, it would have been really boring, and it wouldn't really show more components. But yeah, okay, cool. So it seems that answered the question. Awesome. All right. So maybe let's wait a few more, maybe 1 minute, see if there's any further questions. We have you know, still 1 minute left, and I'm happy to go over, but also happy to cover. So Martin says, great talk, thanks a lot. Yeah, thank you so much, Martin. Yeah, I appreciate it, and would be good to catch up. Yeah, awesome stuff. All right, so I think we're reaching the top of the talk, the end of the talk. So I think we're going to be able to leave it at that note. Once again, thank you so much to the organizers. You know, it's excellent to be able to have these virtual conferences still. So it's an honor to contribute. And you know, I'm looking forward to see everybody on Slack. You know, keen to if anybody has any questions, please do follow up on Slack. More than happy to reply there. So yeah, so with that said, thank you so much to everybody, and yeah, I'll see you in the next few talks. Take care. See you later.